Hello guys, we're looking at question 10. So question 10a says three matrices Q, R, and S are as follows. AI is asking us to explain why the matrix product QS is not possible. So the product of QS is not possible because the number of columns in Q is not equal to number of rows in S. So if we write down the order of these matrices, we'll see that Q has 2 rows and 2 columns. I'm highlighting the columns in Q, and R would have 3 rows and 2 columns. So I'm going to highlight the number of rows in S. These numbers are different, so these two matrices cannot be multiplied. Guys, we're looking at question 10a II. It asks us to state the order of the matrix product SR. So we're going to write down the order of each of these matrices. The order of a matrix is given by the number of rows times the number of columns. So we're going to write down the order of S. So S is a 3 by 2 matrix. And we're going to also write down the order of R. R is a 2 by 2 matrix. So if the two inner numbers are the same, meaning the columns of S is equal to the rows in R, then it means that they can be multiplied. And the outer numbers are going to give us the order of the matrix product SR. These numbers are highlighted in yellow. Therefore, the order of the matrix product SR is 3 by 2. We're looking at question 10a, part III. It is asking us to calculate the matrix product QR. So we have to write down these matrices in the same order. So we're going to write Q first and then R afterward. Then we're going to multiply the rows of Q with the columns in R. So we're going to have 2 times 1 plus negative 1 times negative 5. Then we're going to have 2 times 6 plus negative 1 times 4. Then we're going to move to the next row. So we're going to have 4 times 1 plus 3 times negative 5. Then we're going to have 4 times 6 plus 3 times 4. So let's put these in brackets and then we're going to simplify. So we're going to have 2 times 1 gives us 2. Negative 1 times negative 5 gives us a positive 5. 2 times 6 gives us 12. And negative 1 times 4 gives us negative 4. 4 times 1 gives us 4. Minus 3 times negative 5 gives us negative 15. Next we're going to have 4 times 6 gives us 24. Plus 3 times 4 gives us 12. And we're going to simplify this. So 2 plus 5 gives us 7. 4 minus 15 gives us negative 11. 12 minus 4 gives us 8. And 24 plus 12 gives us 36. And B, it says, given that A is the matrix 4 minus 1 minus 7x, determine the value of x when the determinant of A is equal to 5. So the determinant of a matrix is found when we find the product of the leading diagonal and subtract the product of the non-leading diagonal. In this case, the leading diagonal is 4 and x, and the non-leading would be negative 1 and negative 7. So we're going to go into that now. So we're going to write an equation. So the determinant of A will equal to the leading diagonal, which is 4 times x, minus the product of the non-leading, which is minus 1 times minus 7. So just be careful with that negative sign there. I'm going to put these in brackets. So let us simplify. So it's going to be 4 times x gives us 4x, minus negative 1 times negative 7 gives us 7. Because the determinant of A is 4x minus 7 and also 5 as highlighted in yellow, we can equate these to find the value of x. So the equation will be 5 equal 4x minus 7, and then we're going to have 5 plus 7 will equal to 4x. So if we simplify this, it means that we're going to have 12 is equal to 4x. So the next thing that we're going to do, we're going to divide both sides by 4. So it's going to be 12 divided by 4 is equal to 4x over 4. If we simplify that, 4 into itself 1, into 12 goes 3, 4 into 4 1, so 3 will be equal to x. Then C says that in the diagram below, OPQ is a triangle. ARB and AOQ are straight lines. B is the midpoint of PQ, R is the midpoint of AB, OR to RP is equal to the ratio 1 to 3. It also states that OP is equal to 4A and OQ is equal to 8B. Find, in terms of A and or B in its simplest form, the following. To do this, we are going to put the information that we have on the diagram. So it's important to know that OR to RP, the line is divided into 4 parts and OR has 1 part out of that, while RP has 3. So if OP is for A, it simply means that OR is going to be A and RP is going to be 3A. And we know from O to Q would be 8B. So let's put that in as well. So let us look at I. I is asking us to find the vector PQ. To find PQ, we would have to travel from P to O and then from O to Q. So if you notice, we're traveling P to O, which is the opposite of OP, and OP is 4A. So PO is going to be minus 4A plus OQ, which is 8B. Vector PQ is minus 4A plus 8B. Part II is asking us to find the vector PR. So if we look carefully on our diagram, we can see that we have RP being 3A. So PR would be the opposite of that because we're going in the opposite direction of the arrow. PR would be minus 3A. Part III is asking us to find the vector RB. So to get from R to B, we would have to go from R to P plus P to B. We know that RP has a value based on our diagram, so that's going to be 3A, and PB is going to be the same thing as half of PQ, and we have that worked out in part I. So it's going to be equal to 3A plus a half of PQ, which is minus 4A plus 8B. Simplify, so it's going to be 3A, and we know that a half of minus 4A is going to give us minus 2A, and a half of 8B is going to give us 4B. And let us simplify. 3A minus 2A will leave us with A or 1A, plus what's over there, which is 4b. So RB is equal to A plus 4b.